Hey, this is Linda Hatch with Help with Online Math, and today we are going to talk about how to divide exponential expressions. I'm going to give you a minute to write down this example, and we're going to get started. Okay, in this particular example, take note of some things. Number one, you always want to make sure that you have the same base, whether it's in the numerator or denominator, because that's the key thing that you have to always look for. Now that I know that I have the same base, I can do this several ways, okay? And I'm going to show you how we actually came up with our rule. And I'm going to expand it out. So I have 6 2's being multiplied, divided by 3 2's being multiplied, okay? So if I wanted to, I can divide these out or cancel out, as you might want to call it. And every time I cancel out, I get 1 because 2 divided by 2 is 1. And what do I have left over? You're going to write down whatever you have left over, whether it's in the numerator or denominator. And that's 2 to the third power. So all I did here was I subtracted 6 minus 3, which is the exponents, and I got 3. Okay? All right? Seem pretty straightforward? All right, let's do another example. I'm going to switch to it. And I'm going to give you a minute to write it down before we get started. Okay, here we go. All right, in this particular example, I have something in the numerator as well as the denominator, and I've got to make sure that I have the same base. Now, when we're dealing with the coefficients, what we generally look for is here is a common factor to see if it can reduce in that way. So I can do that because I know that 25 and 10 have a common factor of 5. So if you want to think of it like this is really what you're doing, okay? You're going to say 5, come on here, 5 times 5, and you got y to the 8th power. I'm not going to expand it out because I want you to get in practice with using the actual algorithmic process. And you've got 10 is 2 times 5. If I were to break these down into prime numbers, that's all I did was break 25 down into 5 and 5, and I break 10 down into 2 and 5. Okay? Then I'll put my y to the 4th in the denominator. All right? So now my 5's are going to divide out, and that'll leave me with 5 over 2. And I know since I have the same base as y here, I'm going to subtract this out. So 8 minus 4 is going to give me 4. So my final answer is 5y to the 4th all over 2. See how simple that was? All right, let's do another example. I'm going to switch to that screen, give you a minute to write it down, and then we'll get started, okay? Okay, let's check out this example. In this particular example, I have coefficients of 27 and 12, and then I have x to the third, x to the first in the denominator, y to the fourth in the numerator, y to the third in the denominator. So remember, when we're dividing exponential expressions, we're going to subtract out the exponents of those variables that have the same base, okay? And we're using our exponent rules. Now, if you can't remember how to reduce the coefficients, you can always do this. You can always just off to the side somewhere, break it down into its prime factors. So it's 3 and 9. It breaks down into 3 and 3. I'll do the same for 12. And that's 3 and 4. So whatever is at the base of the trees that's in common, that's our common factor, okay? That's our greatest common factor. So when I divide this out, I'm going to divide this into 3 and 9 in my numerator, 3 and 4 in my denominator. I'm going to just keep it like that as the 9. No need to go any further. And I'm going to cancel those out. So I have 9, and I'll have x to the third power minus 1, x to the third minus 1, and y to the 4th minus 3, because remember, I'm subtracting out my exponents, and I'm going to keep that 4 in the denominator, because I'm going to have for my final answer 9x to the second, y to the first, all over 4. And I don't have to write that exponent when it's a 1. It's an understood 1. Okay? All right, seems pretty straightforward. Join me again. I'm Linda Hatch, and I'm with Help with Online Math. And in our next video, I'm going to talk about negative exponents.